Hello everyone, this is BK Sinha, Physics Chemistry from JNB of Tripura. I welcome everybody in today's class. Today we'll discuss on the topic chemical reaction and chemical equation from the chapter 1 from class 10 science. I hope students, after watching this video, you will be able to define what is chemical reaction, how to balance the chemical reaction, and the various types of chemical reactions. Okay, nice students. So let's start our class with the help of pen and paper. Students, first of all, let us learn what is called chemical reaction. As you know, students, in nature so many changes are taking places. For example, you know, the hydrogen is there in the atmosphere, oxygen is also there in atmosphere. So under certain conditions, this hydrogen and oxygen, they react with each other to form water. Okay, and this kind of changes, here you see the when hydrogen combines with oxygen, it gives water. So water is a new substance. So why? Because the uh, property of water, it it is different from the properties of hydrogen and the properties of oxygen. So hydrogen is something different, oxygen is uh, some other thing, but when they react with each other, they give a totally new substance. Okay, this kind of changes are called what? Chemical changes. And such kind of chemical changes are called chemical reaction. Okay, so let me write this one in this way. So when hydrogen hydrogen gas reacts with oxygen gas, okay, it forms water. This is what is called the chemical change. So there are various factors, or you can say the characteristics are there to uh, understand whether a chemical change or chemical reaction occur or not. Okay, you can understand whether a chemical reaction occur or not either by looking at the change in state, change in color, change in temperature. So these are the characteristics of a chemical reaction. Now the question is, always it is not possible, okay, to write these uh, chemical reactions, okay, in the form of lines. So here, in order to modify them, we can transfer this kind of chemical reactions in the form of equations. Okay, so let us try to write the uh, equations of these particular chemical chains. Okay, so I'm simply writing in this way. Hydrogen I am representing in this way, hydrogen, so plus oxygen is giving water. Okay, so here you see hydrogen I have represented in the form of word, oxygen in the form of word, and the water is also form of the word. So this is a kind of equation. So students, you must know this kind of equations are called word equation, because here all the chemicals are represented in the form of words. So this is simply the word equation. So you can say this is word equation. Now in class 9 we learn the symbols and the formulas, and we learn how to write the chemical formula of different compounds. Okay, so here you see the symbol, and let me represent this particular equation in the form of symbol. Here the symbol of hydrogen, everybody know it is what? The H2. It is in the gaseous state. Okay, let me write in the gaseous state. And the oxygen, the symbol of oxygen is O2. It is also occurred in the gaseous state. So it gives the water, and the formula of water is H2O, which is generally at normal temperature and pressure we can find in the liquid state. Now students, you will say here, see this one, I have represented this particular chemical reaction in the form of chemical formula. So that's why this kind of equations are called chemical equations. So you learn what here, what this is what is called chemical equation. This is called the chemical equation. Okay, so now I should say this equation is not a balanced equation. Why? If we look at here, this part, the left hand side part and the right hand side. So one thing, let me tell you, whatever we have represented on the left hand side of the arrow mark, these are called the reactants, and this part is called the product here. Okay, so here in this particular equation, the reactants are the hydrogen and oxygen, and the product is here H2O. So let us see here in the reactants, the number of hydrogen is 2. 2. There is 2 atom of hydrogen, and in the product number of hydrogen is also 2. Okay, very nice, it's equal. But in case of oxygen, look at here, there is 2 oxygen atom in the reactant, but in the product only 1 oxygen atom. So the number of oxygen atom is not same in both hand side. So as a result, somehow if we want to make it equal, so I have to multiply this H2O molecule by 2. Very nice. So by multiplying this H2O, the number of oxygen becomes 2, but at the same time number of hydrogen changed. Why? Because and this clearly shows that there is and the number of hydrogen is 2 to the 4 hydrogen, but here only 2 hydrogen. So let me make it 4 hydrogen by simply by multiplying this one by 2. Okay, so in this way this chemical equation becomes what? Balanced. Okay, and this kind of chemical equations are called what? Balanced chemical equation. So something you might be thinking that why should a chemical equation be balanced? Okay, very nice, it's a very important thing. Actually, in class 9, we learned that according to the law of conservation of mass of the reactant must be equal to the mass of the product. Okay, in order to follow the law of conservation of mass, a chemical reaction should be balanced. Okay, now in this particular step, I taught you, I have given you the information that how to balance a chemical equation. I have shown you, first of all I have counted the number of atoms involved each of each kind of the reactant, and what I found that number of oxygen is not same in both end sides. So first of all I have made the number of oxygen equal by multiplying H2O by 2, but at the same time it changes the number of hydrogen. So again I have made it equal, this number of hydrogen equal simply by multiplying the hydrogen by 2. So this is nothing but called the trial and error method. Okay, so a chemical reaction, or you can say the chemical equation, can be balanced simply by trial and error method. Okay, okay, maybe in the first attempt you your equation may not be balanced, but again you try it. So that's why it is called trial and error method. Trial and error, and finally you will get the balanced chemical equation. So student, this is all about what is called the chemical reaction, what are called the word equation, and what are called chemical equation. But one thing is there are some equations which are called skeletal equations. Okay, since let me tell you that suppose this reaction I am again writing H2 plus O2 is giving you H2O. Okay, if I ask you that is this equation is balanced, you will say that no, it is not balanced because the number of oxygen is not same in both hand side. Okay, so such kind of equations are called skeletal equation. Okay, so This is called skeletal equation. This is called balanced chemical equation, or you can say the chemical equation, and this is called the word equation. So students, let us move to the next topic. The next topic is nothing but the types of chemical reactions. Types of chemical reactions. Okay, so there are various types of chemical reactions are available. Out of these, only few types are given in your syllabus, and they are nothing but number one is the uh, combination reaction. Combination reaction. Another type is decomposition reaction. Decomposition reaction, and then displacement reaction, and finally you can say the double displacement reaction. Double displacement reaction. So now we'll learn these various types of chemical equations by simply giving you some examples here. So once again, I'm telling you the types of chemical reactions are combination reaction, decomposition reaction, displacement reaction, and double displacement reaction. Okay, fine. So let's start with this combination reaction. So I'm simply giving you an example here. Combination reaction. The example of combination reaction, very simple. For example, hydrogen plus oxygen combines to give you H2O. This is an example of a combination reaction, student. Here you see in the reactant more than one reactants are there, but in the product only one product. So we can define combination reaction in this way. More than two or more than two substances reacts to give a single substance is called a combination reaction. So it's very easy. Suppose another reaction, carbon, when it burns in oxygen, it gives what? Carbon dioxide. So here you see the reactants are more than one, and the product is only single product. So such kind of reactions are called the combination reaction. Now is what the decomposition reaction. Very nice. Decomposition reaction. So here let me tell you, suppose the water H2O. Okay, if we pass electric current, if we pass the electric current to water, the water will decompose to give you H2 plus O2. So students, here you see in this particular equation what we found, that there is only single reactant is there, but the products are more than one. Okay, so this kind of reactions are called decomposition reaction, where reactants are the single one and the products are more than one. So that means a single reactant gives more than one product. Okay, such kind of reactions are called what? Decomposition reaction. Once again, let me give you another example. For example, the calcium carbonate CaCO3. If we heat calcium carbonate, then calcium carbonate will broken down into calcium oxide plus carbon dioxide. So once again, look at here, there is also only one single reactant and the product is more than one. Okay, so let's compare this combination reaction and decomposition reaction. Here you see in the combination reactions, products are single product, but in decomposition reaction the reactants are what? Single reaction. So if we look at these two type of reaction carefully, we can say that they are inverse of each other. Okay, they are just opposite of each other. In combination, more than one reactant. In decomposition, only single reactant. In combination, single product is forming, and in decomposition, more than one product is forming. Okay, so this if you ask anytime by anybody the what is the difference between combination and decomposition, you can easily answer these questions. Okay, very nice. Now student, let's move to the another one, the displacement and the double displacement. So let me tell you about the displacement and double displacement. Displacement reaction. Okay, in a displacement reaction, let me give you a simple example. For example, I have written here iron. This is the symbol of iron. Iron plus copper sulfate. Iron plus copper sulfate. Okay, a little bit focusing problem is there. Okay, no problem. It is clearly visible here, the iron plus CuSO4. The here the products are FeSO4 plus CEO. FeSO4 plus Cu. Okay, very much. Now it is visible. Displacement reaction. I am giving an example. Iron plus copper sulfate is giving you ferrous sulfate plus copper. So it is clearly shows that you see here in the place of in copper sulfate, you see the copper sulfate changes to what, ferrous sulfate. So very simple here, the place of copper is replaced by the iron here. That means iron, it is the iron displaces copper from copper sulfate. Okay, so once again I'm telling you, look at the change here. This is the copper sulfate and this is the iron sulfate. So if we carefully compare these two, the place of copper is occupied by iron only. That means iron displaces copper from copper sulfate. Such kind of reactions are called for displacement reaction. Now students, let me try another one. Suppose I'm telling copper and I'm writing here the FeSO4, and here you see you can expect here CuSO4 plus Fe. But students, this reaction do not occur. The reason is that here, to give copper sulfate, copper has to displace iron. That means copper should be more powerful than iron, but it is not actually. As copper is generally less reactive than iron, but iron is more reactive than copper. That's why copper cannot displace iron, but iron can displace copper. So in the displacement reaction, generally the more reactive element displaces the less reactive element from its salt. Okay, such kind of reactions are called the displacement reaction. Okay, now let us move to the next type, that is what is called the double displacement reaction. DOUBLE, double displacement reaction. So let me give you the information, or let me give you some example of double displacement reaction. From the example we'll try to learn what is called a double displacement reaction. Okay, simply once again I'm writing here, um, suppose silver nitrate, I am writing AgNO3 plus sodium chloride NaCl. It is giving you AgCl, which will appear as a precipitate, plus NaNO3, sodium nitrate. So students, look at here. This is, I will say that this is a double displacement reaction. Okay, let us look at this reaction carefully. See here, this is silver nitrate and this is what, silver chloride. Okay, so compare these two, the changes, silver nitrate changes to silver chloride. Once again, silver nitrate changes to silver chloride. So what happens here, the silver remains the same here, the nitrate, the position of nitrate is occupied by what, chloride. So we can say that the nitrate is displaced by chloride. Again you see the NaCl here, NaCl, and here it is what, NaNO3. Now I am comparing this NaCl and NaNO3. So what we can say that here the sodium remains the same, but the Cl, the position of Cl is occupied by the NO3. Position of Cl is occupied by what, NO3. So what we can say that here NO3 displays Cl, right? But in this case you see the Cl displays NO3. So we can say they are displacing each other. So once again you see the silver nitrate, this one AgNO3, and this is what is called NaNO3. So here you see what happened, silver nitrate changes to sodium nitrate. That means silver nitrate reacts with sodium chloride to give sodium nitrate. It means what, silver is displaced by sodium. Silver is displaced by sodium. Now this one and this one, sodium chloride by reacting with silver nitrate changes to silver chloride. That means sodium chloride is converting into silver chloride. So clearly it shows that sodium is displaced by silver. Okay, so here both these reactants, they displace each other. That's why this kind of reactions are called what, double displacement reactions. So students, today in this class we have learned what is called a chemical reaction, and how to represent the chemical reaction in the form of equations. So we learned the equations, maybe of word equation, maybe chemical equations maybe of skeletal type or the balance type. Okay, and we also learned how to balance a chemical equation. uh, Also we have learned the types of chemical reactions, such as the combination reaction, decomposition reaction, displacement reaction, and double displacement reaction. Okay students, further I recommend you to go through the NCERT book of this chapter, go through the details of the chapter, and go line by line, all activities go through, and try to solve the exercise questions. Definitely you will be benefited by these classes. Thank you very much.